All right. Well, hi everyone. My name is Daniel. I am the CTO and founder of Bow. Instead of jumping into a description of what we do, I thought I'd set up a video to do that for me. So just
We are Bow, the creators of a revolutionary neurorobotics software engine that is harmonizing robotics to a common API and bridging them to the world of digital infrastructure. We started back in 2020, and by 2021 we demonstrated our teleoperation app to the BBC, built upon the Bow SDK and already capable of controlling 2 robots. Later in 2021 this increased to 4 robots, first adding Tiago, which could be controlled for bomb disposal, and then with an underwater ROV, controlled over a 4G connection to pick things up on the sea floor and perform underwater bomb disposal operations. In 2022 we returned with vastly improved communication. We had 5 new robots controlled with the same SDK, and we demonstrated real-time control of a robot across different continents. Keeping the same teleoperation app and only updating the Bow SDK, we were able to control a Tiago robot in Sheffield, UK from a VR headset in Toronto, Canada, performing dexterous tasks with just 10 megabits of bandwidth on conference Wi-Fi. This is real-time control of robots in VR, directly connected to the robot without a proxy. But we wanted to push the limits of our SDK further and operate with higher fidelity and for longer. So in 2023, we created a cockpit that allows an operator to control any robot for 4 hours at a stretch. We tested with various operators whose lives would otherwise be on the line without the robot and demonstrated our SDK can support high-resolution video, high-density tactile capability, and force feedback, providing incredible immersion. The same application, but enhanced with state-of-the-art operator hardware. This is the power of Bow, a single SDK that can control any robot from any operating system, using any programming language, and from anywhere in the world. We provide complete separation of software and hardware, so you don't need to spend months learning hardware, but can instead get started in less than a day without any robotics experience. Bow, harmonizing robotics.
now putting aside the outdated branding and the outdated tagline, which is now for all robotics. Really, the vision is still the same. Our vision, and it's a pretty big one, it's unlocking the next golden age of humanity through a collaboration revolution in robotics. So what that means is we're unlocking the next phase of humanity by enabling robots to be easily used, easily deployed, and easily programmed. And our mission to enable that is building a universal software platform for robotics and a community around that, so that we can go from the state that robotics is in today, where it's really difficult, there's a lot of blocks and a lot of knowledge that needs to be learned before you can even start, to a point where anyone can deploy a robot in their own house. So what you'll find today is that getting into robotics is a really risky journey, and deploying robots is even riskier, because today you need to first find a robot that you like, that you think might do the task that you want it to do. You buy it, you start learning that robot. That will take about 3 months if you're a master's in robotics, and then you start creating the application. And then maybe after a year, you figure out this robot doesn't really do what I really want it to do. And that's what you have today, and you have to do that in Linux. Very few people are comfortable with Linux, alone to use it all the time, and with a limited set of programming languages, Python or C++. So what we're doing is we're enabling development for all robotics, and specifically for all form factors. To date, we've done 16 robots in real life that you can control from the SDK, and 150 robots in simulation that you can control. And that spans all possible types that a robot could take, whether it's a humanoid like the Optimus robot from Tesla, or an industrial arm, ground vehicles, quadrupeds like Spot the robot from Boston Dynamics, which you're probably all very familiar with, and drones, whether they're aerial or underwater. They can all be controlled by the same SDK. And how it works is there's two pieces of software. There is the robot driver, we call it. It is software on the robot that receives universal commands and then translates them in real time to robot-specific commands to get the robot to do and carry out the objective they've just assigned to the robot, and taking care of all the planning, all the movement that needs to happen around that. And then on the other side, you have the Bo SDK. It is a drop-in library you can drop and use into a lot of different programming languages. We've got C++, Python, C#, both for .NET and for Unity as well, and we'll be releasing Java and JavaScript as we go along. And it really simplifies the creation of applications because we also provide this layer, the communication between your software and the robot. Robot could be anywhere in the world and you could be controlling it from your laptop. And so we're providing all the plumbing that will enable someone to very quickly get started creating and testing and starting in simulation. Start programming, test with all the robots available to you in simulation, and then you make a hardware commitment and buy that robot. So here's what the product looks like.
Alright, so I've got
I'm just going to
here
mute
the,
this video and talk over it instead.
and I've loaded up.
There we go. So this is a very simple keyboard control script made in Python, controlling a robot, one of the robots that we have available in simulation. And really what it boils down to is 3 different commands. There's a quick connect, which connects you to the robot that you want to connect to. There's a get modality, which gets all of the information for a specific sense from the robot, vision, audio. And there's a set modality, which allows you to control the robot's movement. So I'm doing this here, got a live view of what the robot is seeing. I'm able to control all the different types of movement, whether that's walking about, whether that's controlling the arms or controlling the head. And then a very quick and simple utility here with a list of all the robots available, and I can immediately connect to a robot that's 400 miles away, doing exactly the same thing, looking around, live view from Scotland while I'm in Sheffield, and controlling the robot in exactly the same way. So even this is pretty special when it comes to robotics, because the robot in simulation is programmed in a completely different way than the real robot is programmed in. And so for all intents and purposes, it's like programming for 2 completely different robots. In this case, they have the same body, but we're pretty agnostic to the body anyway. So, like I said, you simulate first, you buy later, you don't need to do any code changes, and you can finish your software, and then decide whether you even want to buy hardware, because you could just post your solution online as part of the asset store that we're building. And then others will pay you for the software that they then deploy to their robot without you ever having to know about the hardware that you're addressing. And so the code works with any robot, both past, present, and future. So your code you create today could work once Tesla eventually releases their Optimus robot, for example. So yeah, that's a quick intro to Bo. We are releasing our commercial release in April. If you want to sign up to hear about us more, simply go to usebo.com. There's much more information there. And any questions?
All right, so it's really impressive, Daniel.
Thank you.
And I know you've been working on this for a very long time. And I know that you intended to bring a robot with you tonight
Yes.
to show everybody. Tell us about that robot and the kind of who makes it and the deal that you've got with that company.
Yeah, so the robot is manufactured by a Chinese company called Deep Robotics, but it's being resold through a German company, which is completely revamping the software. They're removing all the software that the robot comes with, putting on new software, which is more secure, and part of that solution is our software, Bow SDK and the Bow driver, to enable it to be easier to program and also more secure. The company is called InMotion Robotics. They also have other robots that they'll be releasing, including quadcopters. So we're very much looking forward to working with them. It's a very new deal now, and it's very exciting. It will be the first.
So they're integrating your SDK.
Yes, straight onto the robot.
Into their robot.
It'll be the de facto way to program that robot.
And this is before you've released your commercial product, which
exactly. So we'll be coinciding the two. They're launching their robot at Hannover Messe in April.
Yeah. That's a big trade fair.
Very big trade fair, and we actually have two manufacturers that will be running our software at that trade fair. InMotion Robotics and Sarcomer Dynamics, which is a manufacturer from Canada, which does dexterous hands. So yeah, we're very, very proud of that.
And what kind of robot is the InMotion one? What's the robot called?
Oh, the robot called the Light 3. It is a quadruped robot intended for academic use. And then they will be releasing later down the line a larger quadruped for search and rescue.
Okay. Wow, fascinating. It's a shame that we couldn't have it because it's essentially a robot dog, isn't it?
Yes. It's a smaller version of the Spot robot from Boston Dynamics. Yes.
But without all the gun turrets and everything.
Yes, yeah.
So actually, that brings me on to flippant, but it brings me on to the question. I mean, you showed someone in military fatigues inside your cockpit, presumably for bomb disposal. So obviously, military applications for drones and robots are really, gaining a lot of really hot topic. Do you see? I mean, obviously, you're looking at the whole market, right? You're not looking at a particular niche or specialism. You want to become the de facto kind of middleware, if you like.
So where we draw the line is the use of robots for defense, but not for offense.
Okay.
So that's why the applications we've done today.
So search and rescue, but not search and destroy.
Search and rescue, exactly. It's been bomb disposal, nuclear decommissioning, and also medical assistance in hazardous environments. So think events like Salisbury, where you had the Novichok poison.
Yeah.
Yes, you'd be able to send a robot in to investigate, to provide medical assistance, rather than sending a person in, therefore keeping everyone as safe as possible, while still providing assistance. So that's where we draw the line. Lot like other companies at Boston Dynamics, they have a big thing around providing these robots for also defense applications, but without the offense.
So are you? I mean, not to stick on this topic necessarily, but are you writing that into your license agreement?
Yes.
So as a company, you don't necessarily know what the company's developing or what's on their R&D pipeline.
Exactly.
But your license says, you can revoke it if
exactly.
Okay. Excellent. You showed a lot of applications around remote control. Presumably, obviously, robots can be autonomous as well.
Yes.
So how do you see people using it to create autonomous behaviors?
So that's the reason why we're releasing next month. The telepresence application has been available for a really long time, but it's moving from an SDK that is targeted towards teleoperation to one that is targeted towards more autonomous applications. But the two aren't exclusive. They're not exclusive from each other. So autonomy has different levels to it. You can start from level 0, which is zero autonomy, teleoperation, all the way to level 5, which is fully autonomous. But along the ways, you'll have various different scenarios and different levels where you will want teleoperation and capability in order to take over control of the robot. And so the great thing about this is the data that's being generated by someone teleoperating the robot goes directly towards training not just that robot, but also other robots, because the data is also robot agnostic. So you have not just a way of a failsafe for deploying robots, which aren't yet fully autonomous, and the majority aren't, unless they're in very, very specific use cases. And not just a fallback, also a way to generate the data. And you're generating the data in the tasks that the robot knows the least. So it's even better in that scenario, in that you're always sort of filling in the gaps and leading more and more towards full autonomy.
Okay, so if I understand this correctly, basically you want your robot to do as much as it can.
Yes.
Before saying, I don't know what's going on now.
Exactly.
Yeah, like an autonomous vehicle, a bag blows across the road and it stops because it can't quite interpret what's going on. And you want to reduce those things. You want the robot to understand more and more of those scenarios. And so you have to generate a lot of test data, but using your SDK, you can borrow everybody else's test data.
Precisely.
In order to fill the gaps, as you say.
Yes, but also you're generating that data. If so, robot encounters a situation it doesn't really know, it will sort of call back home, and you get someone teleoperating the robot to carry out the task. While they're teleoperating and carrying out this difficult task, that data can be collected to then train the next iteration of autonomy.
Yeah.
And it really speaks to a big problem in the realm of robotics. So you might know that OpenAI, they had a big robotics section to them, which they stopped completely because the thousands of hours needed to train a single type of robot to perform a couple of small tasks is just so prohibitive to do that they stopped pursuing it altogether.
Yeah, there's too much risk because you're expending an awful lot of effort, which is then locked up in a particular device by a particular manufacturer.
Yes, exactly. So what we're providing is a way to collate all that data. And the ideal scenario is you'll be able to train multiple robots from a concentrated set of data points.
Right, yeah. So one final question just about Sheffield and your company, the project. Has it come out of Sheffield Robotics? Is that where you started?
Yes. So I was a researcher there for 6 years at the University of Sheffield, originally from Malta. Came about 10 years ago. Did 6 years of research at Sheffield after my master's. And that's where I encountered the problem. Because I started with one robot, which took me 6 months to learn. And then 3 years later, we needed to switch to a completely new robot. And that's where I realized that most of the code I'd done over the last 3 years needed to be rewritten. And initially I was like, surely there must be a better way to do things. I must have taken a wrong turn, chosen the wrong tech. But I asked and everyone had pretty much the same responses, like, no, you just have to tough it out and work through it.
That's just where we are right now.
Yeah, and I didn't like that. So I started to apply the sort of bit of my research within Sheffield, which was focused on neuroscience and psychology and human memory, replicating that in robotics, and applying principles from neuroscience and developmental biology to create the representation that is robot agnostic. And so that's what really sets us apart. It's quite interesting how approaching robotics from a neuroscience perspective rather than a mathematical one can lead to easy solutions for what would otherwise mathematically be very, very complex.
And easier interfaces, presumably, for people who don't need a PhD in robotics. So
exactly. Yes. We're doing the hard work so others don't have to.
Brilliant. I don't know if you've got a couple of minutes, but does anybody have a question for Daniel just before we close out? Yeah, one at the back.
Why do you think that robotics implementation is so different to automation of machines, traditional factory automation, stuff like that?
Because traditional factory automation to date has relied on a static task that you're assigning to a single robot. And so you didn't really need our stuff. You could program that task, and it would then just do it over and over and over again. But what you find is with the advent of Industry 4.0 is we're moving more towards just-in-time manufacture, where you have a set of devices, a set of robots, and you want to be able to allocate them dynamically to carry out this task or that task as may be needed. And so you'll find that you need dynamic code. You need to be able to dynamically tell which robot what to do and not care about what type of robot it is, especially if you're looking at manufacturing over a large geographic region where the robot that is available to you here isn't available to you, for example, in China or in Japan. And so you'll need to recreate the code to get that Japanese robot to do the same task. And so this is where that comes in more handy, because you can define your task once and then deploy it to any robot dynamically.
Okay. Talk to Daniel afterwards when
Please.
we all break and have drinks. I'm sure there's plenty of other people with good questions, but really good luck with the launch next month. Thanks so
Pleasure.
much for talking to us. Cheers, Daniel.
Thank you.